We are on 5.3. 5.3, normal distribution. Z value, okay, let's review this a little bit, then we move on to 5.4. I will share the screen with you. Perfect. So last time we talked about Z values, Z scores, and we learned how to use our table and also calculator to convert each Z value into, each X value into Z value. Very well. So in today's lecture, we're going to see how we can find Z value connected to the given probability. Okay, perfect. So this is our goal. Finding Z scores. So last time we had X value. So in previous lectures, we had X value. And our goal was to find Z, which is equals to X minus mean divided by standard deviation. Then we either look at the table or we use our calculator to find the probability.
Is this a 5.3?
Yes.
Perfect, thank you.
Now here you have the probability. Here you have the area. Your goal is to find the Z score. So you have the probability and your goal is to find Z value. Let's take a look at one example to see what's going on. Example 1 says, very well, find Z score that corresponds to cumulative area almost 36%. Very well. We know we have a table. If we look at our table and find the area or probability in between the table, in between these numbers, which are 0 to 1, we find the closest number to 0.3632. Closest number 3632. We're lucky. We have this number in the middle of the table. Now our goal is to find the Z value. Remember that the Z value has some decimal numbers on the first column and on the first row. So the Z value corresponds to 0.3632 is going to be negative 0.35. Z negative 0.35. And the probability of this Z less than equals to negative 0.35 is equal to 0.3632. So you either have your probability, you find your Z, or you have your Z and you find the probability to the left-hand side. The same process using your table, or you can use your calculator. So you have no information about Z, but you have information about the probability. The probability or cumulative area to the left is given. So you have to look for the closest number in between the table, in between, somewhere here. You have to either look at your positive z-values, negative z-values.
Ali, ask a question so we can
Something.
hear you.
So you have to find the closest number inside the table and then find z-value corresponds to that area. Let us take a look at the second question. It says 10.75%. 10.75%, it means that you have your area or probability. Area or probability is given here. You're looking for your z value. Okay, perfect. 10.75%, you have to find that number in the table. Okay, so take a look at the question one more time. It says the area to the right-hand side. The area to the right-hand side. Remember that your table has all the information about the area on the left-hand side. Question 2 says it's the area on the right-hand side. Since you have your probability, you have to do a little bit of algebra. 100% minus 10.75% is almost 89%. So 0.8925 is area inside the table. So you have to look for that number in between these decimals. Again, since the question says it's area to the right-hand side, we have to do a little bit of algebra. This algebra is 100% minus 10.75%, which is 0.8925. We have to find that number here inside within the table, not on the first column, first row. Inside within these numbers, 0.8925, which is this area here. Now that we have the area, the corresponding z-value is 1.24. Z is 1.24. Very well. Example 2. In example 2, the question says, find z-score given a percentile. Remember that when we talked about percentile, we talked about the areas. The first one is the 5th percentile. The 5th percentile. It means that you're looking at 5% of the area to the left-hand side. 5%. 4.05. Very well. We can look at our table. Let me pull up the table here for you. Z table. Z table PDF. So I can write on it. Perfect. So 5%. 5%. Okay, I have to look for 5% within these numbers or these numbers. I have two tables, positive z-values, negative z-values, and I have a lot of probabilities or areas. Perfect. So let us find 5%. Here you have to just look for that 5% somewhere inside the table. Okay, perfect. So what do we have here? Here we have 3%. Here we have, okay, 6%. I'm looking for 5% or the closest number to 5%. This is 0.049, which is closest to 5%. So this is my 5%. This is my 5%. So the z-value is negative 1.65. 5%, closest number to 5%, and z-value is negative 1.65. That's my z-value.
I had a quick question for you, Professor.
Go ahead.
Wouldn't it be between 1.64 and 1.65, or?
You can take the average as well, of course.
Oh, okay.
Of course.
So either or would be correct on a test?
On the test, because 5% is halfway between two areas on the table, the z-score is halfway between negative 1.64 and negative 1.65, which is negative 1.645. This is the exact number that you get by using your calculator. The second one says the 50th percentile. 50% of the area to the left-hand side. 50%. 50% or 0.50. For this 50th percentile, you don't have to use your table. You already know that half of the area is to the left-hand side of z equals to 0. So your z is nothing but 0. That's it. So if the question says, find a z-value for the area or probability to the left or right, it doesn't matter. The z is going to be 0. Lastly, the 90th percentile. 90% of the area to the left-hand side. 90%. So let's take a look at our table. We're looking for 90% to the left. Okay, 90%. So as you can see, the first table only gives you 36%, 40%, and 50%, and more is on the second table for positive z-values. So let us look for 90% here. 90%, the closest number to 90%, let us find that, is going to be, okay, 0.89973, or you can work with 0.9147. So the z-value corresponds to this area is 1.28, 1.29. By taking the average, you can actually find the z-value. Let us move on. So also know that if we have our x value, if we have the mean, and if we have standard deviation, our z follows the formula x minus mean divided by sigma. Now, what if you have your z, you have your mean, and you have your standard deviation? Can you find your x? Of course. X is equal to mean plus z times standard deviation. So we can transform standard z-score into an x value, which is the actual value in the collection, actual value in the data that you have. By following the formula, x equals to mu plus z times standard deviation. Let us take a look at one example to see what's going on. So in this question, here the information that you have is about a vet records the weights of cats treated at a clinic. The weights are normally distributed with a mean, which is 9 pounds, and the standard deviation of 2 pounds. So what information are given? Mean is given, mean is 9, and standard deviation is also given, sigma is equal to 2. Question says, find the weights. X corresponds to the following z-scores. So z-scores, 3 z-scores are given. Your goal is to find the weights. Perfect. We have to follow the formula that we just learned. We know that x is equal to mean plus z times standard deviation. Our first z value is 1.96. We plug all the information into the formula, and x is equal to mean, which is 9, plus z, which is 1.96, times sigma, which is 2. You multiply 2 by 1.96 plus 9, and the outcome, the actual x value is 12.92 pounds. The second z value is negative 0.44. We have our z, we have the mean, we have the standard deviation, we just plug them in. So x is equal to 9 plus z, which is negative 0.44, times standard deviation, which is 2. You multiply 2 by negative 0.44 plus 9, which is 8.12 pounds. Next z is equal to 0. So our x is equal to the mean, or 9 pounds. We don't have any unusual value here. Unusual values are values greater than 2 standard deviations or less than 2 standard deviations. Very well. Next. Finding a specific data value for a given probability. Very well. So let's see what do we have here in this example. Scores for the California Police Officer Standards and Training Test are normally distributed. So for sure we know that we have a normal distribution. The mean is 50 and standard deviation is 10. An agency will only hire applicants with scores in the top 10%. Okay, so no percent lower than 90% is acceptable. What is the lowest score an applicant can earn and still be eligible to be hired by the agency? Only top 10%. Very well. Okay, so what's given? Area to the right is given, which is 10%. First of all, since this is area to the right-hand side, if you do a little bit of algebra, 1 minus 10% gives you 90%. By looking at your table, you can find that the z value corresponds to 90%. Okay, let's take a look at our graph. 90%, 90%, which is an area in between these decimals. We're looking for 90%. 50%, 60%, 70%, 80%. Okay, I'm getting closer and closer to a number close to 90%. I don't have the exact value for 90%, but the closest number is 0.89973. The z-score corresponds to 90%, is closer to 1.28. You can take the average of 1.28 and 1.29 and get the exact value. So your z is equal to 1.28. We're looking for x value. What is our x? We learned a nice formula how to transform z into x. My z is 1.28. My mean is given in the question. My mean is 20. My standard deviation is also given in the question. Mean, mu, 50. Z, we just found z using the table, 1.28. And sigma, standard deviation, is also given in the question. First, multiply 1.28 by 10, which is 12.8. Add it to 50. X is equal to 62.8. The lowest score an applicant can earn and still be eligible to be hired by the agency is 63. Now, how do we use our calculator to find the z value? By using TI-84, go to second. In the distribution, you have to find inverse norm. Again, second, distribution, find inverse norm, and in the parentheses, you have to write the probability or the area. Then enter, it gives you the z value. Next example, finding a specific data value. In a randomly selected sample of women ages 20 to 34, the mean total cholesterol level is 181 milligrams per deciliter, with a standard deviation of 37.6 milligram per deciliter. Assume the total cholesterol levels are normally distributed. Find the highest total cholesterol level a woman in this 20 to 30 age group can have and still be in the bottom 1%. So what's given? The mean is given. Standard deviation is also given, and we know that it is normally distributed. Bottom 1% is the key here. So first of all, we're looking at the area on the left-hand side. What do we have? We have the area. So area is given 1%, which is 0.001. We can look at our table, or we can use our calculator inverse norm. Z value corresponds to 1% is negative 2.33. In the next step, your goal is to find X value. What is your X? We have our mean, we have our Z, we also have our standard deviation. Mean is 181, Z is negative 2.33, and sigma is 37.6. First, multiply these two numbers, then add by 181. Your X is approximately 93.39. So let us get back to Canvas. Go to the rest of chapter 5, 5.4. Let us download the PDF file so we can write on it. Very well. So far we learned that we have normal distribution like the height, the weight, shoe sizes, IQ scores, and so on. I expect you to ask, what if I don't know anything about the shape of the distribution? What if the shape is not normal, or I don't have any information about that? What you can do, you can work with either the proportion or the mean of your sample. This method is called sampling distribution of either the proportion or sampling distribution of the means. Let us look at the official definition. A sampling distribution is the probability distribution of a sample statistic. This sample statistic can be either the mean of the sample, X bar, or proportion. That is formed when samples of size n are repeatedly taken from a population. If the sample statistic is the sample mean, then the distribution is the sampling distribution of sample means. Every sample statistic has a sampling distribution. So suppose you have a population with mean mu and standard deviation sigma. The mean of the first sample is x1 bar. The mean of the second sample is x2 bar. The mean of the third sample is x sub 3 bar. The mean of the fourth sample is x sub 4 bar. And the mean of the last sample is x sub 5 bar. We can continue this process and create a new data using the means x1 bar, x2 bar, x3 bar, x4 bar, and the rest of them. You can repeat this process 1,000 times. There is no restriction there. it turns out if you work with the mean of the samples instead of the actual X values, the mean of the population is equal to the mean of this new sample, and standard deviation of population is equal to square root of n times standard deviation of this new sample. This is called central limit theorem. So the standard deviation of sampling distribution of sample means is called standard error of the mean, which is denoted by sigma sub x bar, and it's equal to sigma over square root of n. Let us take a look at one example. So a sampling distribution of sample means you can write the population values 1, 3, 5, and 7. You can randomly choose 2 slips of paper with replacement. Then you can list all possible samples of size n equals to 2 and calculate the mean of each. These means form the sampling distribution of the sample means. Okay, question says find the mean, variance, and standard deviation of this new sampling distribution, which is sample means. Compare your results with the mean mu equals to 4 and variance sigma squared equals to 5 and standard deviation 2.236. First of all, when it comes to sampling distribution, we're going to just use this example to present how it works. In reality, in industry, they use softwares to form sampling distributions or means or proportion. So they took these values, sample 1 and 1. The mean 1 plus 1 divided by 2 is 1. What if you pair 1 and 3? The mean is 2. If you pair 1 and 5, the mean is 3. If you pair 1 and 7, the mean is 4. 3 and 1, 2, and the rest of them. These data are new data for sampling distribution of the mean. If you use your calculator, add them all together, divide by the total number of entries, you find the mean. Use your calculator by entering these values to find the standard deviation and do a little bit of algebra to find your variance. These new data form a probability histogram. So as I mentioned, this theorem is called central limit theorem. First of all, if you don't know anything about normality, you have to check the condition that n for the sample size is greater than equals to 30. Second of all, if you form the sampling distribution of the means, then the mean of the population is the same as the mean of the sampling distribution of the means. Also, the variance of sample means is the variance of the population divided by n. At the same time, if you take square root of both sides, you can form the standard deviation of sample means sigma sub x bar, which is equal to sigma, or the population standard deviation divided by square root of n. Very well. So these are different types of populations that you might see. If you have any population distribution, then by forming a sampling of means, you see the new distribution is normal. If you already have a normal distribution, the sampling distribution of the means is also normal. Let us take a look at an example to see what's going on, how we can apply central limit theorem. So here you have cell phone bills for residents of a city with mean $47. So the mean is given. Standard deviation is also given, which is $9. You have random samples of 100 cell phone bills. So n is equal to 100. N is already greater than 30 and we're fine. The question says, find the mean and standard deviation of sampling distribution of sample means. So we're looking for mu sub x bar and sigma sub x bar. We're looking for these two values. Based on central limit theorem, since n is 100 and it is greater than equals to 30, we can move on and use central limit theorem. Central limit theorem says the mean of sampling distribution is the same as the mean of the population. And in the question on the first line, we know that the population has mean equals to $47. So it's the same as the mean of sampling distribution. Second of all, the standard deviation of sampling distribution is equal to standard deviation of population divided by square root of n. Do we have information about standard deviation of population? Of course, it is 9. So you have 9 divided by square root of 100, which is 9 divided by 10, or 0.9. So we found information about this sampling distribution of the mean. From the central limit theorem, because the sample size is greater than 30, the sampling distribution can be approximated by a normal distribution with mean 47 and standard deviation 0.9. The graph of sampling distribution is like this. The mean is 47 and standard deviation of sampling distribution of the means is smaller than the standard deviation for your population. That's why you see less spread in your sampling distribution of the means. Very well. Next. So in this question, we have the training heart rates of all 20-year-old athletes, which is normally distributed. So you have a normal distribution. We don't care about the sample size. N is not important. We already know that we have a normal distribution. The mean of the sample is, the mean of the population is 135 and standard deviation is 18. Random samples of size 4, so n is equal to 4, are taken from the population. Question says, find the mean and standard deviation of sampling distribution of sample means. By using central limit theorem, since we have a normal distribution, we can move on to the formulas. The mean of sampling distribution is the same as the mean of the population. The mean of the population is given, which is 135. So the mean of sampling distribution is 135. Standard deviation of sampling distribution, however, you have to do a little bit of algebra. It's standard deviation of population divided by square root of n. Standard deviation of your population is 18 divided by square root of n, which is 4. 18 divided by 2, which is 9. So your sampling distribution of the means have the same exact center with smaller standard deviation.